A fuel pressure regulator creates pressure by restricting flow. Depending on how the regulator fails, it may create too much pressure by over-restricting the flow or too little pressure by under-restricting the flow. If the test value for idle pressure is high and idle volume is low, or vice versa, this is a good indication of a malfunctioning pressure regulator. In addition, if the values for peak pressure and volume are both good, it would support this diagnosis because these values are generated while fuel was bypassing the regulator. In this case, replace the fuel pressure regulator and retest. If all 4 test values are low, this would indicate a performance issue with the fuel pump. Check the fuel pump electrical circuit and power supply. Only if they are good should you replace the fuel pump and retest. On a returnless fuel system, at idle, the pressure gauge will indicate the fuel pressure in the system. Make note of this value. Observe the float inside the clear flow tube. It should be at the bottom or very near it. This is normal because the only fuel flowing through the system is what the engine needs to idle. Locate the flow control knob on the side of the FST and rotate it clockwise past the closed position and toward the bypass position. Fuel will begin to flow from the bypass port on the side of the flow meter and the float will rise to indicate the volume. Continue to rotate the knob until the volume indicated by reading across the top of the float is equal to the maximum engine volume requirement you looked up earlier. Once you've dialed in this volume, make note of the pressure reading on the gauge, then return the knob to the open position. If the vehicle stalls during this test, simply return the knob to the open position and restart. The test you just performed simulates a load on the fuel delivery system as if the engine were performing at peak horsepower. It's critical to an accurate performance diagnosis because many malfunctions won't become evident unless the engine is under load. When performing this test, you are bypassing the volume of fuel equivalent to the engine's peak demand. At that point, the pressure noted on the gauge is the peak demand pressure. It represents the pressure the fuel delivery system is capable of producing when the engine is using its greatest volume. Having now collected values for idle pressure and peak demand pressure, compare them to the manufacturer's pressure specification. If the fuel delivery system is functioning properly, idle pressure should meet the specification and peak demand pressure should be within 10%. If this is true, then the fuel delivery system is capable of performing to meet the engine's requirements at peak output. However, if idle pressure is out of specification and/or the peak demand pressure is greater than 10% below spec, then the fuel delivery system is malfunctioning. While a performance test will determine if there is a malfunction, additional testing should be performed to pinpoint the cause of the malfunction and support the final diagnosis. While idle and peak demand pressure are a good indication of the capability of the fuel delivery system, a bypass test to determine the peak volume output of the fuel pump is critical to pinpointing a malfunction in a returnless fuel system. During the bypass test, fuel is allowed to flow unrestricted from the tester in order to determine the peak volume capability of the fuel delivery system. To perform a bypass test, turn the flow control knob from the open position 180 degrees clockwise to the bypass position. While in the bypass mode, note the peak flow by reading across the top of the float on the FST flow meter. After you've recorded this volume, return the knob to the open position. If the vehicle stalls during this test, simply return the knob to the open position and restart. Performing a bypass test in addition to the original performance test will yield values for idle pressure, peak demand pressure, and peak flow for the vehicle. All of these values must be taken into consideration when making a final diagnosis. Start by listing the test values you obtained for idle pressure, peak demand pressure, and peak flow. Compare the idle pressure to the manufacturer's specification. It will be either low, normal, or high. Peak demand pressure will typically be slightly lower than the idle pressure. Consider it normal if it's within 10% below the manufacturer's spec. If it's greater than 10% below the spec, consider it low. If it's higher than the specification, consider it high. When performing a bypass test for peak flow, it is normal for the volume to reach over 0.7 gallons per minute. If the value for peak volume is less than 0.7 gallons per minute, consider it low. Using these criteria, indicate on your list of test values whether each is low, normal, or high. Now review your list of test values. If all the values are normal, the fuel delivery system is operating normally. A restriction to the fuel supply reduces the flow of fuel to the engine. The method employed for regulating the pressure, whether it be a pressure regulator or electronic control of the fuel pump speed, can typically compensate for small restrictions. However, as the restriction increases, fuel volume will decrease until the engine is starved for fuel. If idle pressure is normal, yet peak demand pressure and peak flow are low, this is a typical indication of blockage in the fuel supply, possibly caused by a clogged fuel filter or inlet strainer or pin supply line. If the test values indicate a restriction, replace the fuel filter, inspect the fuel supply lines, and retest. If the test results are the same, you'll need to inspect the fuel pump to determine if it has a clogged inlet strainer or some other source of blockage. Once you've located the blockage, repair it and retest. A mechanical fuel pressure regulator creates pressure by restricting flow, while a system that regulates fuel pressure electronically does so by varying fuel pump speed. In either case, depending on how the regulating system fails, it will create too much or too little pressure. This will be evident by the test values for idle and peak demand pressures both being low or both being high, while the peak flow remains normal. If the fuel system is electronically regulated by the PCM, follow the vehicle manufacturer's procedure to diagnose this system. If the fuel system utilizes a mechanical diaphragm pressure regulator, replace it if possible and retest. In many cases, the fuel pressure regulator is not replaceable, requiring the replacement of the entire fuel pump module. Before going through this expense, always check the electrical circuit and power supply to the fuel pump. Only if these are found to be good should you replace a module. If an electrical problem exists, repair it and retest. If all three test values are low, this would indicate a performance issue with the fuel pump. Test the electrical circuit and power supply of the pump. Only if they are determined to be good should the fuel pump be replaced. In the majority of cases, a quick test combining the capability of the Mityvac FST with the proper fuel system diagnostic techniques can determine the capability of the fuel delivery system. However, exceptions such as an intermittent malfunction caused by a sticky fuel pressure regulator or loose ground can cause the system to perform flawlessly one moment but fail the next. In addition, multiple malfunctions will significantly increase the complexity of pinpointing a failure. Employing the proper tools such as a pressure and volume tester with bypass capabilities like the Mityvac FST will always provide the best starting point. In cases where the diagnostic test results are borderline or inconclusive, consider connecting the FST in alternate locations, possibly upstream of the filter or on the return side of the pressure regulator. By applying common sense and a basic understanding of fuel delivery systems to the test results, you should come up with the most likely conclusion. And there you have it. With the assistance of the Mityvac FST and this video, you should now be able to accurately diagnose a fuel delivery system. Thank you for your time. See you around the garage.